I promised a bit of walkthrough through Mujoco, and for that we're going to jump to a collab notebook, and also a few people let me know that they were not able to launch Isaac Labs or Genesis, given the the ability of their machines. And I understand that's certainly something that could happen. One of the ways to mitigate that is to run in the cloud, or in the case of Mujoco or Genesis, can be run in a notebook. So here I'm in a Google Colab notebook. I've installed Mujoco to start out with, and then we're just going to run through the basics. This is going to create a box, red 0.2 of a meter. Okay. Okay. And so this is the model that we're going to be using. It's telling me I have an invalid name. Sphere is what we named it. Oh, it doesn't have a name. So, no. Okay. Okay, there's a green sphere. And then we're going to give it some array values. And there's our green sphere. So there's the ID of the sphere, the world, etc. Okay. I'm going to fly through this so we can get to the coolest part. So here we're getting raw access to the kinematics, and now if we were to look through the simulator, this is the outcome. Why is it black? Because we need to propagate the values of the sphere. Now we render, and there we go. Media that chill. So similar, and now we're adding a light. And now we got some different colors, and you can see here, and now we're showing a video very similar to Genesis. I'm going to add some DOF to the, very cool. And now we show the video, so you can see very similar to Genesis. There we have flipped gravity on its head, so now it's trying to float upwards. Okay, so and now we're looking at the degrees of freedom, the model. This is pretty good simulated, opening. I guess I call it a soft opening for Mujoco. You can see here, this is how a scene would look if you render it. Fairly looks nice. And this is showing the positions and velocities. Should all be set to 0. Very static scene. And now here we got a spinning top, and that's awesome. Yeah. Okay. And so just like we did before with Genesis, I can see, all of the values for velocity and angular velocity and stem height. It started at the top and then all of a sudden it was flat, as you can imagine. So this example is a pendulum. So this example here, we have a static pendulum. Just running through the examples here. Now with the pendulum moving, you can see it swinging around. This is another example. Just running through the examples for those of you who haven't seen it. You can see here the total energy expended, and at the point of where it reaches chaos because of the rotations. And this is something you can run in 10 seconds. I'll leave the link in the description how to run this. But you can see how, you know, Genesis and these compare. Both can be run in a notebook, and both run fairly quickly. So we're going to go back to that sphere example and give a free joint here. So here is the box and sphere, and now we're going to make that fall into the floor, and you can see we're also the TF and frames, we're seeing that in this visualization. This is where Genesis isn't ready yet, is contact forces, those kinds of things. So that's where I think they are in their process, is they don't have fundamental forces yet. But you can see here, you know, here I'm creating two boxes, and this is the material. There's a wall, there's a box, and yeah, literally what's happening is I'm saying, well, I'm not saying anything, but the forces of friction are available to us now because we have, you know, set this up so that there's a friction coefficient of 0.33. Again, that's probably where we're not at yet with Genesis. Here it looks like, I haven't looked at this one before creating this video. Looks like we're creating a cylinder, we have light, the floor anchor, something's anchored to the floor, a box in a sphere, and tendon. So this is something that I'd be interested in, is understanding how it treats tendons. And this is, yes, what's going to happen when you actuate. Very cool. Yeah. And so then you can plot again, and then you can see going to advanced rendering. So here we go. We're back again with the red box, and looks like we have TF visualized, and so frames visualized, and transparency looks like a little bit. Cool. And looks like in this one we're going to visualize the depth of the same, so I can see the depth here, which is needed. I can segment them. Yes, I'm not using the GPU. Sorry, I will shortly. And then here, this is going to render camera images and showing the box positions of the box. Do the same thing for the circle. And then looks like we're going to add some just random geometries to the scene. I'm going to draw some colors. Oh, there it is right there. Cool. Oh, so it's going to follow the position of the pendulum swinging and basically draw some colors. Again, this is just the starting tutorial, so you can see essentially what goes on humanoid. So there we go. And let's back up here. So we have an XML definition of humanoid, and again, like we did before, we can change this for any other Mujoco file. And yeah, there's our humanoid. Pretty sick. Okay. And let's see the code here so we can see what we're looking at. Free joint, seesaw wrapper. Cool. So the domino effect. And, this is using, again, I could install this locally and do the same thing, and it would be fairly quick as far as the performance is concerned, just like Genesis. We're just running through these. It's not like we're doing anything of our own. Here we go again. I could probably ask Gemini or OpenAI to tell me what this is actually going to do, because while I can read code, I don't think I would be able to tell you what this is supposed to do just by knowing these numbers. But it should be doing something at some point. Or maybe not. There we go. Oh, cool. Yeah. Oh, amazing. I think the coolest part about that was the camera following the action. Track motion, here it is. Yeah, I mean that's really cool especially if you're rendering full-fledged scenes. And now I can just do that in code. I don't have to worry about, so I'm going to back all the way up and kind of show you where this all came from. Of course. Click, 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 click. Should be like a couple more. There we go. So I'm going to install Mujoco, and here are the basics: timing, contact forces, tendons, all of that stuff, camera control, all there. And to get here, let's see, to get to Mujoco, there is a I'll just put it here. If I Mujoco, you can see the docs here and the programming reference, simulation, visualization. Here's some code samples. So in the tutorial on how to go about some of the basics in Mujoco. So you can see it's fairly similar to what Genesis aspires to be, and as a plugin directly for Unity. Yeah, runs on Linux, Mac, and Windows. I use the models from Mujoco, but I don't tend to use Mujoco because there's just other places, other ways you can do this. Isaac Sim and Isaac Labs still has a lot of my attention for this purpose, but this is so much simpler with so much less processor. It's just a matter of which tools you're going to invest your time and energy in to learn. And I already know Isaac Sim, Gazebo, and others, so it seems to me Genesis is a great tool once it's all done, and so I'll probably be using a combination of Ross and Genesis, and even Isaac Sim. As time goes on, all of them together.
All right.
Have a good one.